Hello, welcome back to today's class, Stochastic Processes. My name is Sondolo from Godobin. Alright, now since we have a basic understanding of some terms, then we can now go into the definitions of stochastic processes. And don't forget, if you are not watched the lesson 1 of this course, so kindly just go back and watch the lesson 1. There we defined random experiment, what its sample space is, and then a random variable. So knowing that, we can now go to the definitions of stochastic process. So a stochastic process is a mathematical model. It's a mathematical model that describes the evolution really of a system over time in a probabilistic manner. So what's the meaning of these definitions? That means that we want to employ mathematical model to describe how a system changes over time. How a system changes over time. So that is stochastic process. So that means that every system around us changes over time. So how does that changes occur? What is the evolutions of a system over time? So we try our possible best to employ mathematical model in order to check how did the weather change over time. When we flip a coin, how does that coin changes over time? When we are dealing with a particular drug, how the drugs, what is the effectiveness of the drug over time? When we are trying to observe a particular phenomenon, a dynamic system now, so we try to check what happens to that systems over time. So by using mathematical model. So another definitions that I believe can convey this concept more clearly is it consists, stochastic process consists of a collection of random variables indexed, in other words, script indexed by time, majorly by time, sometimes can be other parameters or another parameter. Represent as S index T, representing the state of the system at different points in time. So another way we can just denote it using a notation, S subscript such that T belongs to capital letter T. Alright, our T usually denotes time. Sometimes it can be another parameter, but majorly it denotes time. And this set T, okay, let me just write it separately. T usually denote time. Denotes time, and then T is the set of the time space time space. Alright, so in a short form, we can define stochastic process as you can just say that at every time t, in the set t, a random number s subscript t is observed. So our t can be in seconds, can be in minutes, can be in hour, can be in a day, can be monthly, can be yearly, as the case may be. So just take note of that stochastic process just has to do how a system changes over time, in probabilistic manner, that is uncertainty. So we just try to make use of our mathematical concept equations and the rest in order to represent the changes of a times over time, at time 0, at time 1, at time 2, etc. So another concept I would love it to define before we go to some examples that will give us proper understanding of this concept is what we call the state space. So in stochastic process we have what we call the state space. The state space represents as X is the set of wave value values that your random variable can take. It represents all possible states or configurations of a system. In the stochastic process. Or in a dynamical system. So for example now, if the system we are dealing with is weather, example, weather, maybe that is the dynamical system we are dealing with. The possible state a weather can be is that either the weather, maybe at today, maybe the weather is raining or is sunny. We can say that is the configuration of the weather climate, either it is raining or it is sunny. And if the system we are dealing with, for example, is if a six-sided die, you know that a six-sided die is configured to have phase 1, phase 2, phase 3, phase 4, phase 5, phase 6. So I believe with these two examples you understand what a state space is. It's just the state of wave value that ST can take. That is all possible states of a particular system. Okay, so we can also have another example like a semester. If a school in Nigeria is semester, the possible state we have in semester is the first semester and second semester of a particular year. Alright, so but this state now we can classify it into two. So we have two types of states, classification of states now. Let me change my pen. Classification of state space, that is the possible state of your dynamical system classification of state space. So your state space can be one, a discrete state space, a discrete state space. For example, weather forecasting now, we know that it can either be raining or it is sunny. Raining or sunny. So that is a state space whereby you can able to count the number of possible states of that particular system. So such space is called discrete state space. The second type of state space we have is continuous state space. For example, now we just denote a state space X to be 0, close boundary is 0, 3, and let's use infinity. So we cannot easily describe that we have 5 numbers between 0 and infinity, because if we represent this is it can be written as x such that x is less than or equals to 0 and x is less than infinity. So we have infinite number between the range of 0 and the infinity. So short state space is called continuous state space. Please kindly take note of that. So I will stop here for today. So I will continue, and I hope to see you in the next lesson, whereby we'll be having a number of examples of stochastic processes. Then we're able to classify the types of stochastic processes we have based on the state space and the time t we have. Alright, see you in the next lesson. My name is Sunday Oluwafemi.